Hi! Today we're going to talk about the beginnings of BIOS programming. We're going to get you all the tools that you need to get started. You may have noticed I have a very long Hello World program out there, and it covers what the boot sector is and the BIOS and how to get these tools that you're about to see installed and then build a Hello World program. And it goes off on little tangents here and there with little endian and all of that. And um, my sound card was not great. There's a hiss in the background. It it is all inclusive. So if you just want everything, that would be the place to go. I'm trying to break this up into smaller videos. I'm trying to cover the things more in depth that are applicable, and then by having multiple smaller videos rather than just watching this entire lecture dissertation going on and on and on. Hopefully you can just find what you're looking for. So anyway, let's get going. Our goals are to get you these tools installed. I am using Visual Studio Code right there. And we'll talk about the proper formatting for the BIOS to work, a makefile to make your life easier, and then we will clear the screen. So if you are on Windows, I would suggest you get WSL. It's the Windows subsystem for Linux, so you can run Linux on top of your Windows. It will make programming a lot easier. I would suggest you get Ubuntu. I believe that's very easy to get, if I remember correctly. And I'm using Linux Mint, which is a derivative of Ubuntu. So I can just do sudo apt install the flat assembler, and then qemu, still don't know how to pronounce that. If you don't know exactly everything you want to type in, you can hit the tab key a couple times and it shows us all of this stuff. And we want to do x86 programming. So we're going to do system x86. Hit enter and ta-da! Everything is installed. Perfect. All right. On your machine, it might not be, so it might take just a little bit longer than that. Now, for the extensions, I have a lot of C++ extensions, and I probably will cover that in a C++ video. I probably actually already have, but hey, why not? Why not do a reset button on that too? So, looking at this now, I would recommend you get the hex editor, which looks like this. If you type in hex editor, it'll find it. It's from Microsoft. You can install it. The flat assembler highlight. This is not by Microsoft, but it is a very helpful extension. And also makefile tools is handy. And I also have WSL apparently in here as well. I would get that. Honestly, it's just something that would be handy to have. Makefile tools is here. So we got all of those things installed. I would recommend you install those things. All right, let's move on to actually programming, because that is the fun part, right? Well, one second. Let's see what happens if we run the emulator without any inputs. All right, so it shows us a bunch of words. It says it cannot boot or read a boot disk. It's trying the network right now. Skynet is not online, so there's no terminators coming, and we're not able to boot off of the network. So, yep, nothing will run. Fair enough. Now let's look at code. So if we look at this code here, we can see that we start out with U16. We're going to be doing 16-bit programming. It's in real mode. It's not in protected mode. Our origin point is 7C00. This is a requirement. The BIOS will be looking for 7C00 as the start point. That is the beginning of the boot sector. After that, as we covered in the boot sector video, a sector is 512 bytes long. So we will fill the memory with 510 zeros. and then we'll write 2 bytes at the end. And if you watch the What is a Byte video, the hexadecimal characters each represent a nibble, which is half of a byte. So please check that out if that is interesting to you. And that is a word because it's 2 bytes. Now you might be wondering, what is this time stuff? What's going on here? Well, in this example, there is no other code in here. So we are basically at the 0 address. Or 7C00. Relatively speaking, we're at 0. So this is our current address, 0, minus the beginning, also 0. 510 minus 0, 510. So write 510 zeros. If we were to assemble this right now, it succeeded. It's 512 bytes. It did 1 pass. And if we look at our little handy thing here, oh, we can't open it. Yes, we can. We got the hex editor. So here we go. We got lots and lots of zeros. Very exciting. And at the end, we have 55AA. You might wonder why we did AA55. And to quickly explain, this is little endian, which means that the processor stores memory addresses backwards. Now, there's a reason for that, and honestly, I don't really feel like I should get into it, because you're here to see code. Well, mainly, you're here to see if your tools work. So let's just prove real quick that it stores it backwards. So we have 1, 2, 3, 4. I switched this from a word to a double word, and that means I need to get rid of 2 bytes here. Save that. Up arrow gets us our last command. Hit enter again. We will look at this, open it in the hex editor, and you can see 55 AA 34 12 55 AA 34 12. There we go. We have proven that it stores the memory in backwards. I might do a video on that because there's going to be somebody that's like, why on earth does it do that? So we can talk about that at some point. All right. Well, we've assembled this. Let's assemble it again now that we changed it back to valid code. And since it is valid, let's run it, right? Well, we need to actually put in the drive that we're trying to use. So we'll put in our emulator again. We need to specify that we are adding a drive. Its format is raw. It's raw binary. And the file is our input.binary, the thing that was created by the assembler for us. This looks different. It says it's booting. It's doing absolutely nothing, but it does not say I cannot find a bootable disk. We have succeeded. So now I'm going to take this time to talk about the makefile. So when you create a makefile, make sure that the F is lowercase. And it's going to be real exciting when you look at what is in the makefile. The makefile for all, which is going to be our default target, says run the flat assembler and assemble the file, which is this line of code. If you run make run, it says run this line of code, which is identical to what we typed in. So you might be thinking, well, why did we go through the work of making a makefile? I will show you why. In the case of running make, which is running this flat assembler, that's not too bad. I can type in FASM and the name of my input file. MAKE is much faster, but I can do that. But honestly, remembering to type all of this in every single time, yeah, that could get tedious. So by just typing make run, we can run this and it will do it automatically for us. You can see why this would be helpful. All right. Well, next on the agenda, we're going to talk about clearing the screen. So let's do that. And then this video will be done because we will have installed all of our tools. We will have tested all of our tools. And we will show that the code we're entering actually does do something. We won't really get into what it's doing, why it's doing it, and everything else. But in the next video, the next Hello World program, where we go into some depth on this, we will talk about what it's doing and why it's doing it. So needless to say, follow along everyone. Let's just type in move AX, comma, 0x03, which moves move 3 into register AX. We'll talk about registers in the next video as well. And after that, we'll do run interrupt 10H. All right, let's do a make. Let's do a make run. We have an empty screen. We have cleared the screen. All right, congratulations, everyone. Your tools are working if you see these things. If you had any issues, please leave some comments. I will try to assist you with that the best of my ability. And we look forward to seeing you in the next video where we will be doing another Hello World program. But we have hit the reset button. So by doing this, it allows you to, well, not have to watch 47 minutes of a bunch of stuff that you might not necessarily care about or already know about. We will see you then.